What is good, 7th graders? We are doing some examples on SP8 probability. So we have to find what is the probability of getting a purple marble and then a green marble. So we see there's one purple. We're doing our want over total again. There's one purple out of 3 marbles. So what we want is the purple one out of a total of 3. And it says you pick a marble, you put it back, and then you pick another one. Okay? So that means I will still have 3 marbles the second time when I pick. If I would have kept the marble, I would have only 2 to choose from the second time. So that does make a big difference. But I put it back, so I still have 3. Now I want the probability of getting a green one. There's 1 green out of 3 marbles. I multiply those together. 1 times 1 is 1. 3 times 3 is 9. So the compound probability is 1/9. Good. All right, you pick a card at random without putting the first card back. You pick a second card at random. Okay, so now this would be dependent. We're going to keep the cards, so that's going to affect what we can get the second time. All right, so we want the probability of green. We have 1, 2, 3, 4, 5 cards, so it's 1 out of 5. Then the probability of yellow, which there aren't any yellow, so that would be just 0 over 4. Well, 0 times anything is 0, so it would just be 0%. So let's plug in 0. Good. All right, what is the probability of getting tails and then getting heads? You flip a coin twice. Well, one side out of 2 is tails, and one side out of 2 is heads. Multiply those together. 1 times 1 is 1, 2 times 2 is 4. So the probability is 1/4. You pick a marble and a card. How many outcomes are possible? Okay, so we have 1, 2, 3, 4, 5, 6 marbles to choose from, and 3, 4, 5 cards to choose from. To figure out how many outcomes are possible, we just multiply those together. Multiply how many marbles there are with how many cards there are will give us the total possible outcomes. Okay, which in this case is 30. Because for every marble we have, there's 6 of them. Going over here. There's 5 cards that could go with it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All of those get 5. Then if you count all those, there's 5, 10, 15, 20, 25, 30 different combinations that you could have between marbles and cards. So we can either draw a picture like this, or we can just multiply them together to figure out how many there are. Good. Here it says how many outcomes are possible. So again, we'll multiply. A coin has 2 sides. The spinner has 2. Multiply those together. We get 4. So there's 4 possible outcomes. And on this one, we have 3 cards. We have 5 marbles. Multiply those together. We get 15. Different outcomes are possible. All right, you're at a clothing store that dyes your clothes while you wait. The store offers 4 different articles of clothing and 3 colors. If you randomly choose the article of clothing and the color, which of these diagrams can be used to find all the possible outcomes? Okay, so we have 4 articles, 3 colors. 4 times 3 makes 12, so we need 12 possible outcomes. All right, so let's look at this. This has 3, 6, 9, 12. We have the articles of clothing and the colors there. This one has 3, 6, 9, 12. It has the articles of clothing and the colors there. So both of them actually will work. They both give us 12 outcomes with colors and articles of clothing. That's what we needed. All right, you're ordering a one-topping pizza. You can choose from 3 different toppings and 2 types of crust. So 3 times 2 is 6. We're looking at 6 different outcomes. Okay, which diagram gives us that? So diagram A, we can actually just count the bottom row. We have 1, 2, 3, 4, 5, 6 outcomes. So A works. And for B, they did a little differently, but it still has 1, 2, 3, 4, 5, 6 different outcomes. So they both work. Okay, this one did crust first and then toppings. This did toppings and then crust. Both ways work. They both give us all the possible outcomes. Okay, here we have 5 options for the race of the character and 3 options for the main tool. 5 times 3 is 15, so we're looking at 15 different combinations. So we have 5 different races, 3 different tools, that makes 15. 3, 6, 9, 12, 15. And the second one has 5 different, this has 3 different races and 5 different tools. So that's flipped around. Even though it has 15 possible choices, it's not the right choices. We needed 5 different races and 3 tools. They flipped it around to 3 races and 5 tools. So it's just A that works. Okay, you decided you wanted to plant for your room. At the gardening store, there are 4 different kinds of plants and 4 different kinds of pots. If you randomly pick the plant and the pot, what is the probability you won't get a clay pot or a cactus? Okay, for this we have to draw a tree diagram. So 4 different kinds of plants. We have a tulip, a fern, a cactus, and a ficus. There's 4 different pots. So under each one of these, we have 4 different pot choices. We have clay, plastic, metal, and wood. So we need to list that under each one of those. And then it says, what's the probability you won't get clay? So this one is not cactus or clay. Neither of those 3 are. The first one doesn't work because it's cactus, but these 3 work. It's not cactus or clay. None of those work because that's all cactus. First one is clay, that doesn't work, but the last 3 do because it's neither clay or cactus. So that's 3, 6, 9. 9 is our want out of a total of 4, 8, 12, 16. So 9/16 would be our probability. We could change that to a decimal, or change it to a percent, or just leave it as a fraction. I'll just leave it as a fraction. Good. If you flip a fair coin, 3 fair coins, what is the probability that the first 2 flips will both be heads, and the third flip will either be heads or tails? Okay, so we need to draw a tree diagram again. Our first flip, we get heads or tails. Our second flip, no matter what we got the first time, we still have choices of heads or tails. And then the third flip, no matter what we flip the first 2 times, we still have choice of heads or tails, heads or tails, like that. Okay, so now the first 2 flips have to be heads, and the third, heads or tails. So we need heads, heads, and then it could be either one. So both of those work, heads first, and then heads or tails. This is heads, tails, that doesn't work. Tails, heads, tails, tails. None of those work. So it's only 2 that work out of a total of 1, 2, 3, 4, 5, 6, 7, 8. 2 out of 8. Remember, you can just count the bottom row to figure out the total possible outcomes or the total choices. Reduce that fraction, reduces to 1/4. That's our probability, just 1/4. Okay, you're having dinner at a restaurant that serves 5 kinds of pasta and 4 different flavors. What is the probability you'll end up with bow ties, cheese sauce, or both? All right, so let's draw our tree diagram. We have spaghetti, bow ties, fettuccine, ravioli, and macaroni. Then we have 4 different sauces that go under each one of those. We have tomato, cheese, meat, and olive oil. So we'll write all of those down. All right, now we want bow ties, cheese sauce, or both. So this right here is bow ties. So all of those automatically will work because they all have bow ties in it. Now we need to mark all the cheese sauce. So we have cheese, we have cheese, we have cheese, we have cheese. Okay, so we have everything that is either bow ties, cheese sauce, or both bow ties and cheese sauce. So that makes 1, 2, 3, 4, 5, 6, 7, 8. 8 that we want out of 4, 8, 12, 16, 20. 20 total choices. Again, I'm just counting the bottom row to figure out my total choices. Reduce that fraction, what goes into 20 and 8. Let's see, 4 goes into both of those, so that becomes 2/5. So our probability is just 2/5. And the counting principle. How many different combinations of vehicles does Edwin have to choose from? Okay, he wants a car to be red or yellow, so that's 2 choices. Truck to be black, white, or silver, that's 3 choices. Motorcycle to be green, blue, or orange, that's 3. So again, to find the total possible outcomes, you just multiply those. 2 times 3 is 6, times 3 is 18. All right, Bruno is designing his next skateboard. The skateboard store has 3 types of grid tape, 13 types of decks, 7 types of trucks, 4 types of bearings, and 2 types of wheels. How many different skateboards could he create? So we just have to multiply all of those together. 2,184 different possible skateboards that he could make with those options. Okay, 2,184. All right, we have 7 hunting, 7 fishing, 6 hiking, and 3 camping events for this family to choose from. How many expeditions are possible? Again, we just multiply all those together and we get 504 different combinations. All right, that's it. Enjoy your practice.